Everyone, welcome to Science Tech Day. So today I'm going to take you through how capacitors work and the application of the capacitors. But before we go on, never risk yourself to touch the terminals of the capacitor because the capacitor might discharge itself from you or it will shock you. And before I go on very far, capacitors just works just like how a battery works. But the only difference is that capacitor has a less capacity than a battery, and secondly, reason why capacitors are being used in most of our boards, because the capacitors releases its energy faster than a battery. So that's why in most cases it's being used in our boards. And secondly, capacitor in our boards works just like a tank. Let me say a water tank. A capacitor, by the time when you are powering your let me say your radio, the capacitor will store some more electrons in it. So in that, when there is a power interruption, then the electrons which were stored inside the capacitor can be released out in that to cover up the flow of the electrons in your component. That's why in most cases they use capacitors. And so right now, let's go to the makeup of the capacitor. A capacitor is separated using by a dielectric material, and this dielectric material, we have the paper, we have the liquid, and sometimes it can also be separated with an air. And now between these two dielectric material, we have the two plates, which one plate is negative and the other one is positive, whereby when we connect our capacitor to the source, maybe let me say from the battery, the electrons or the voltage will force the electron to flow from the negative part to the positive part. In that, it will force these electrons to cover up or to be filled up in the negative part of the negative plate. These electrons always are in the negative plates of the capacitor. Then when you connect this capacitor, let me assume when you want to discharge it or when you want to power up your bulb after charging the capacitor fully, because now capacitor, when you charge it using a battery, the capacitor will reach a time when they have the same voltage with the battery, then it will stop charging. So when you remove this capacitor and you connect it to maybe your bulb, the electrons which was stored into the capacitor, the voltage will force it to flow from the negative part to the positive part. As you know it, as right now I want to make you know that this capacitor, the negative and the positive side of the capacitor, also just works the way how a magnet works. If you have ever seen a magnet, whereby the like pole repel and then the unlike. So here, the reason why they use this dielectric material to separate these metals is to make sure that they don't allow these the electrons which is already covered or filled in the negative part of the negative metal in the capacitor to flow and go to the positive part of it. So for the electron to flow from the negative to the positive, so you have to connect it, or you have to connect the positive and the negative terminal of the capacitor to make sure that these electrons flows from the negative the positive part of the capacitor. And in most cases, these capacitors are applied for example, when you are using a full bridge rectifier, this capacitor is used to smoothen the DC signal, because in most cases when we use a full bridge rectifier, some AC sign attempt to go through to come out of this rectification stage. So we use these capacitors in most cases to clean up the flow of the DC, such that the current which is coming out from our DC, since that our board can really detect that the AC is coming. So for you to prevent all this, you have to make sure that you use your capacitor to clean up the DC current which is coming from the rectification stage, then it goes out when it's a DC power. And also in other hand, capacitor is also used for in most cases it's used in power correction. What do I mean here? In power correction, for example, when your power is on and off, when your power is on and off, you can use your capacitor to stabilize the power which flows from the source up to where you want your power to go in. What do I mean here? That this capacitor, power enters into it, a voltage which enters into a voltage which forces the electrons to enter into it. Then it stores power into its negative plate. Then when there's an interruption, or the flow of the current reduces, the capacitor will reduce the electrons which was already stored from the negative part of the plate. Then it goes to the positive. What do I mean? When the current flows from the negative then to the positive of the capacitor, you just know your component will be working, but you remember it won't work for some time. So this one will reduce a risk of blowing your component. But remember very well that capacitor has values, and you have to know them very well. So when your capacitor maybe is blown off and you want to replace your capacitor, you have to read very well and you have to know it very well. As you know it very well, that capacitor has voltage. Its voltage are always indicated in the body, and it also has the units which you can measure the capacitance of the capacitor, and the unit which you can use to measure the capacitor, which we use, the unit for capacitance of the capacitor is farads, but in most of our boards we use microfarads. So microfarads looks like something which is having U and F, and farads in short term it's F. So you have to read all that. So when you are replacing these capacitors, you have to read those two values. We have the voltage value, and then we have the farads. And now the voltage value, that is the force which forces the electrons maybe to flow into our capacitor, which forces the electrons to go through the capacitor. So you have to master those values. But now in our capacitors we have two parts. How to see that this part is this leg, one leg is positive and then the other one is negative. So there is a part here which is having something like a white strip. So that's the part, the leg which is that's the part which is negatively charged. Then we have the part which is having nothing. It has no strip. That's the positively charged terminals. So you have to know these capacitors very well. And as I told you, that these capacitors are named after its dielectric materials. So the dielectric materials, as I've mentioned before, we have the paper. We have the paper. We have they can also use a liquid. Some people use some other capacitors has papers. We have air and we have also liquids.